So here we are in section 14, which is basically approaching integrals in a different light. Now this isn't crazy, not at all. What I'm going to do here is I'm going to kill a couple birds with one stone and rewrite that cubed root of x as x to the 1/3. No big deal. But then I'm going to flip it upstairs and make it x to the negative 1/3. Still no big deal. Okay, taking the integral of that is going to have me saying 1 over 1 minus 1/3, x to the 1 minus 1/3. This is indefinite, so don't forget that plus c. 1 over 2/3, x to the 2/3 plus c. Let's multiply the top and the bottom by its reciprocal. 3 over 2, x to the 2/3 plus c. Now I'm going to rewrite this the way God intended. 3 square root of x cubed over 2 plus c. That's how I'm going to end this problem. Okay, you might have a teacher that might be okay with this. I prefer it to look like that. It just looks prettier. So we're going to go with that guy right there. This is section 14 of chapter 6, which allows us to do something and think outside the box a little bit. Now, it wouldn't be the end of the world to do u substitution, but we've done so many u substitutions that I'm going to approach this differently. I'm actually going to FOIL this guy out. Okay, this is a perfect square trinomial. So u become 25x squared minus 10x is minus 20x, and then plus 4 dx, and then I'm just going to integrate this the old-fashioned way. Okay, so u become 25 over 3x cubed minus 20 over 2x squared plus 4x plus arbitrary c. And cleaning this up a little bit is just going to get me 25/3 x cubed minus 10x squared plus 4x plus c. Okay? So sometimes you can avoid u substitution. In a case like this, I did. Evaluate the integral of x squared plus 3, all of which is squared. Now, normally when we see stuff like this, we think u substitution, but u substitution won't work because you would let u equal x squared plus 3, and there's no 2x or anything with an x lingering around, so u substitution, again, will not work. So I am forced to FOIL this guy out. So I'm going to rewrite this as x to the 4th plus, what is that, 6x squared plus 9 dx. Now I integrate that using our typical power rule thoughts. So u would be 1/5 x to the 5th plus 6/3 x to the 3rd plus 9x plus arbitrary c. And then cleaning this up in one more step, we have 1/5 x to the 5th plus 2x cubed plus 9x plus c, and that should do it. Fun. Evaluate the integral of sine x over cos squared x. Well, that is just disgusting and problem. I don't like it. Let's rip it apart. Okay, let's have sine x over cos x times 1 over cos x. Same thing, right? Well, I know that sine x over cos x is tangent x, and 1 over cos x is secant x. Now, we could look at this and be like, oh, I know what's going to happen, but maybe you would rather look at it like this. Secant x, tangent x. Same thing, just worded differently. The integral of secant x tangent x is secant x. And of course, since this is indefinite, arbitrary plus c, can't forget that guy. And now that problem, which looked like an absolute gross mess at first, wasn't so bad, was it? Evaluate 2x plus 1 over the root x. Now we're integrating this guy. I don't like it. So I'm going to rewrite it like this. I'm going to rewrite it like 2x plus 1. Okay, but I'm going to take the fact that I know that you're x to the 1/2 on the bottom, so moving it up top makes it x to the negative 1/2 up top, like so. I'm going to distribute that to both of these. So now I have, now keep in mind, invisible 1, and when you multiply two x's, you add the exponents, so this becomes 2x to the 1/2 plus x to the negative 1/2 dx. Now I can integrate, okay? So 2 just kind of lingers. You would be 1 plus 1 plus 1/2 x to the 1 plus 1/2, right? You would be 1 over 1 minus 1/2 x to the 1 minus 1/2 plus arbitrary c, of course, can't forget that. So the 1 on the left ends up being 2 times 1 over 3/2, I'll clean that up in a little bit, x to the 3/2 plus 1 over 1/2 x to the 1/2 plus c. You become 2 times 2/3 x to the 3/2, and you just become plus 2 x to the 1/2. Oh boy, I did not leave myself enough space. That's all right. We'll write small. Nothing magical happens here. 4/3, right? I will rewrite this as the square root of x cubed plus 2 root x. And maybe one more step is to rip out an x. 4/3 x root x plus 2 root x. I'm going to leave it like that. Not pretty. Definitely not pretty. I'm not happy with the way I ended it. But you know what? It's correct and it's good. And I forgot my plus c. That was a close one. I forgot my plus c. Oof. Definitely not my finest work. Let me quick rewrite it up here where I have all this wonderful space. And I'll even use a thick pen. 4/3 x root x plus 2 root x plus c. Now everyone's happy, especially me. Ooh, I rhymed. Like and subscribe. Evaluate the integral of the 5th root of x over x. Let's change the way this looks. First off, let's change the fact that the 5th root of x is also x to the 1/5, right? So while I'm doing that, I'll make you x to the 1/5, and you're like, whoa, 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 what about the denominator? Let's move that up and make it x to the negative 1st. So times x to the negative 1st dx. Two x's are multiplied together, add the exponents, so this is x to the negative 4/5 dx. Integrating that is going to look like this. 1 over 1 minus 4/5 x to the 1 minus 4/5 plus some arbitrary c. So that's going to be 1 over 1/5 x to the 1/5 plus arbitrary c. Flip that upside down, you get 5. Turn that into the 5th root of x again, plus c. And that'll do it for the AB version of Chapter 6. I hope you had fun.